Hello, in today's video we're going to be discussing section 8.4, which is still on graphing quadratics. However, we're going to be looking at what we call vertex form. So here we have f of x is equal to a times the quantity of x minus h squared plus k. And our essential question is, how are we going to be able to describe the graph of an equation in that form? So first I'd like to recall graphing quadratics in standard form, and I'm going to give us a few little tricks to make this just a little bit faster. So step one, as we talked about in a previous lesson, we're going to identify the vertex by using the formula x is equal to negative b over 2a. This is specifically the x value of the vertex. So here I have an a value of 1, I've got a b value of 2, and I have a c value of 2. So I just want negative b, so that's going to be a negative, and then b is going to be 2 over 2 times a, and I input a 1 for a, which simplifies to negative 2 over 2, or 1. So my vertex is somewhere on the x value of, that should be a negative 1. So over here on the left-hand side, negative 1. So to figure out the exact place, I then input that negative 1 into my quadratic. So f of x is x squared plus 2 times x plus 2, and we are inputting a negative 1 for x. So this is 1 minus 2 plus 2, which is 1. So my vertex is at the point negative 1, 1. So I'm going to go ahead and put that on my graph. Now, our parabolas are always going to follow a pattern. And the pattern might change, but originates from the same place every single time. And here is my pattern. We are always going to go left 3, up 9, left 2, up 4, left 1, up 1, and then the same on the right. So right 1, up 1, right 2, up 4, right 3, and up 9. So if you forget our pattern, all we're doing is whatever we go left, we square it and go up. Whatever we go right, we square it and go up. 3 squared gives us 9, 2 squared is 4, 1 squared is 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now the only thing that might change this pattern is the value of a. We then go ahead and multiply all of our ups by a. So every quadratic starts with this pattern, and then we multiply the ups by the value of a. And in this case, my pattern isn't going to change. I'm still going up 9, because multiplying by 1 does not change the value. Up 1, up 4, and up 9. So then I follow this pattern from my vertex. So from my vertex every single time, I'm going to go left 3, 1, 2, 3, and up 9, which is going to be off my graph. Left 2, starting at my vertex, left 2, 1, 2, and up 4, 1, 2, 3, 4, here I am. Starting back at my vertex, I've done my first and my second. Starting back at my vertex, I go left 1, up 1, so here is my vertex. Left 1, up 1. Starting at my vertex, I go right 1, up 1, so right 1, up 1. Then starting at my vertex, right 2, 1, 2, and up 4, 1, 2, 3, 4, and then right 3, up 9, which is off my graph. So notice that my points are creating a symmetric graph. So if I fold this graph in half, the points on the left will stamp on the points on the right. So that tells me that I probably did a pretty good job when I went to plot my points. So I connect all these dots the best I can and graph my parabola. It should be a smooth U shape, but I have a little bit trouble doing that on the computer. So here is the graph of my function. I'm going to walk you through the first few steps of question 2, and then question 3 is all yours. So step 1, I need to find my vertex by using the formula x equals negative b over 2a. So in this quadratic, I have an a value of negative 2, I've got a b value of negative 12, and I've got a c value of negative 15. So then plugging those values in, I've got negative b over 2 times a, but I am replacing a and b with specific values. So negative b over 2 times a. I fill in this top parentheses with my b value, or negative 12. And then in the denominator, I have a, which is negative 2. Negative 12 make a positive 12 over a negative 4, which divides to negative 3. So the x value of my vertex is negative 3. Now to find my y, I go back and plug that into my function. F of negative 3 is equal to negative 2 times negative 3 squared minus 12x minus 15. But I should have replaced that x with a negative 3 minus 15. So negative 2 times 9 plus 36 minus 15. Negative 18 plus 36 minus 15 is going to be 18 minus 15, which is 3. So my vertex is at the point 3. Negative 3 for x and 3 for y. So negative 3 for x, 1, 2, 3 for y. Now my pattern. My pattern's always going to start with the same. Left 1, up 1, left 2, up 2, left 3, up 3, and then on the right, right 1, up 1, right 2, square it, I get up 4, right 3, square it, I get up 9, and I should actually have a 9 here, left 3, up 9. I multiply by my a value, so looking at a, I see that a is a negative 2, so I multiply all of my ups by a negative 2. Including that negative is extremely important because it's actually going to change our direction. 1 times negative 2 is a negative 2, which actually means I'm going up negative 2 or down 2. Going left 2, I actually should have gone up 4. 4 times negative 2 is a negative 8, which means I'm going down 8. 9 times negative 2 is a negative 18. So up negative 18, which means down 18. Negative 2 means down 2. Negative 8 means down 8. And negative 18 means down 18. Now I graph these the best I can from my vertex. Left 1, down 2. From my vertex, I start back over here at my vertex. Left 2, down 8. Left 3, and down 18 is way off my graph, so I'm not going to include that one. And then on the right, starting back at the vertex, right 1, down 2, right 2, down 8, and then I connect my dots in the most smooth U shape that I can. Now this graph is facing downwards because my a value is negative. If your a value is negative, then your parabola will always be facing in the downward direction. All right, your turn. Go ahead and pause the video and try number 3 on your own. Your vertex should be 2, negative 2, and your graph should look something like the one I have shown. On our next slide, I'd like for you to go ahead and take a moment to pause the video and try these couple on your own before I guide you through them. So what I'd like you to do is graph f of x whatever way you can, and then g of x, you'll probably want to use a chart because this is not in standard form. So for g of x, we cannot use negative b over 2a. So go ahead, take a moment, pause the video, and try out both a and b on your own. F of x in part A is a parabola that has an a value of 1, and it is centered at the origin, so your graph is going to look something like this, with my vertex at 0, 0. In graph 2, g of x, I'll do this one in red. My vertex is at the point 2, 0, and it still has an a value of 1. So we follow the pattern left 1, up 1, left 1, up 2, right 1, up 1, right 2, up 4. So my vertex here is 2, 0. In B, my vertex is still going to be at 0, 0 for f of x. But now we are multiplying all of those up values by 2, so left 1 up 2, left 2 up 8, right 1 up 2, right 2 up 8, and here's my graph of f of x. And g of x looks very similar with a 2 on front. This is my a value. When you create a chart for this one, which hopefully you did, we will find that our vertex is at 2, 0, and I still have an a value of 2. So I maintain the same shape as I did in my f of x graph. So looking at both of these, what I see is simply a difference in vertex. I do not see a difference in the shape other than I drew them a little bit poorly. But the only difference I see is that one of them got shifted over slightly to the right. So my blue graph, my what we call parent function, it doesn't have any special pieces to it. It's just a normal parabola. It got moved 2 units to the right. So this minus 2 caused that to happen. And same thing here. The only difference between these two is that in with the x, I have a minus 2, which caused my graph to just slide over 2 units to the right. So my vertex is now at 2, 0 instead of 0, 0. All right, go ahead and try out these couple. Again, you can use negative b over 2a for your first graph, but then create a chart for your second equation and compare the two graphs. All right, so in both of these equations, I do have a negative in front of my function, which causes my parabolas to face downwards. So in these cases, both of these a values are negative 1. Since f of x is in standard form, you can either use a table for f of x, or you can use negative b over 2a. But for g of x, unfortunately, it's not in standard form, so you must use a table. When we graph them, we see that all that happened is my red graph and my blue graph are very, very similar. The only difference is that the blue graph has a vertex at negative 2, 0 instead of 0, 0. And again, that came from the fact that we have inside our parentheses with x a plus 2, which gave us a minus 2 as our x value for our vertex. Same thing here, I have a plus 2 inside with the x, which gave us an x value of negative 2 at the vertex. So I'd like to think about how we can describe the graph of f of x equals a times the quantity of x minus h all squared. So take a moment to pause the video and write yourself out an answer to that question, and then proceed to describe the graph the best you can of a, b, and c below. So some ideas that I wrote down are that the graph of f of x has a vertex of h0, and a determines the size, in other words the width, and the direction of our parabola. To describe the three graphs below, I see that this will be the last one I walk you through, and then I'd like you to practice the rest on your own. So this one will have a vertex where my x value is a positive 4 and that y value is 0. So my vertex is at the point 4, 0. And then I write out my pattern and multiply all of those ups by my leading coefficient here, which is going to be 1/2. So my new ups are going to be the values that I have shown here. So following my pattern, I can obtain my graph, which is going to look like this. This one did widen out a little bit because our a value is 1/2, causing it to flatten out. All right, go ahead and try this last one on your own. Pause the video and check your answer in a moment. You can pause the video again to look at my work if you need to check your answer, But I'm going to go ahead and wrap up the video here. Thanks so much for watching and have a great rest of your day.